And I'm going to hide this flooring panel since I learned. All right, you guys. So we're going to do today differentiation and integration of a power series. Remember yesterday we did what? What test? We did a ratio test to figure out the radius of convergence. Now we're going to, nice about this, you can take derivative of the power series. You can take antiderivative of power series just like a regular function. Are you with me, class? All right, let's do it now. There you go. Here you go. So, in other words, power series. Okay, the power series. What kind of form is this? What is this? What kind of power series is this? McLaren or Taylor? It's a Taylor, right? The Taylor has x minus c. If the c is a 0, you call it what? McLaren series. Otherwise, it is what? Taylor series. So Taylor series is a little broad. Okay. So looking at this, you're gonna say, okay, I know how to find my radius. I do ratio test, or I do alternating test, I do radical test, I do whatever the test I need to do to find my convergence. Okay, now guess what? You can do exactly like you take derivative of the functions. You can do the same thing with your power series. So your power series is this. You see it? So what would you do if you take a derivative of this? Now you're taking derivative respect to n. Are you with me, class? You're taking a derivative respect to n. So you're taking derivative of this. So how would you do? Remember, I'm not taking derivative respect to x. I'm taking a derivative respect to n. So what would you do? Then that's equal to what? So I'm going to do a sub n. I'm not going to do anything. That's just a number, right? And then times, I take a derivative of n. And then what? X minus c. And then what? N minus 1. That's a derivative, right? Because I'm taking derivative respect to n. So how would you do integration then? Again, I'm taking our integration respect to what? N. Are you with me? Then what would you do? A sub n is just a number. And then what do you do? X minus c, n plus 1, and divided by what? N plus 1. That's it. That's what we're learning today. So does everybody understand? You're not taking a derivative respect to x, but you're taking derivative respect to what? N. So is everybody with me? So this is f prime. What is this called? Integral of f. All right, are you with me, class? So this is what I wrote down. This is what basically saying here. Okay, important part. I want everybody to listen to this. This will make your life so much easier. Read this one. The radius of a convergence of a series obtained by differentiation or integrating the power series is the same as what? Original power series. In other words, that means I have a choice. I can use function to do the ratio test. I can do what? Derivative to ratio test, or I can do what? Integration of a ratio test. I will choose whichever is easy for me. Because it says, theorem 9.21 says, whichever you do, function or derivative or integration, you do your convergence test, whatever that is going to be your radius of convergence. That's a keyword. It's very important. Is everybody with me? This is very important. It gives you so much leeway. You will just choose whichever is easy for you to use to find the radius of convergence. All right, let's go and do it. So we're gonna do these 3 problems. We're done with the 9.8. Okay, so consider the function. So this is your function with your power series. All right, it says, find the integral of convergence for each following. So let's see, what's this one first? Let's just find what this means. This means I'm taking what? X to the n over n and dn, right? That's what that means. Integration. I'm integrating respect to n. So that means I have x to the what? I'm just gonna add one more power to this. That's what we need to do. All right. So actually, it is not really taking n in consideration. So I'm not okay. So I was wrong about you are taking derivative with respect to x still, but it'll be one more power. So it's still x. Are you with me? It's still x. I said it wrong. So you're looking at the x, n is a number. Are you with me, class? Okay, so how would you do this? So 1 over n is just a number, so I don't do anything. So take antiderivative of this. What's that equal to then? X to the n plus 1 divided by what? N plus 1 and plus c. But c is just a number. I don't have to worry about it right now. So let's rewrite this one. So what do you have then? X to the n plus 1, everything over what? N times n plus 1. All right, I want to go one more step because I want to use P series a little later. So that is your antiderivatives. The function you already know. How would you find the f prime? F prime will be just like that. So 1 of n, I don't have to do anything. So it'll be n times x to the n minus 1. What do you get now? You just have x to the n minus 1. All right. So in other words, what can you say? Which one is easiest to use? Because remember, the 9.21 says I can use either function or antiderivative or derivative, whatever the one is easy for me to work with, I can choose that to find my convergence. So what do you think is the easiest one to use? Derivative, definitely. Why? Look at this, how this one is antiderivative is definitely what most complicated. And this one is pretty good, but it has a denominator over n. But look at the look at the derivative. It doesn't have a denominator. It just have x to n minus 1. So I would definitely use what? This to do what? Convergence test. So yes, looking at this, I would definitely use that. Is everybody with me? Okay. Moving on. Okay. By theorem 9.21, you have this, right? Antiderivative. So I would definitely use this one. So you have 1 plus x plus this. I will use this one. And antiderivative is this. We got that. Totally done it, right? Previous page. So you got this is this is a derivative. This is antiderivative. We got that one. Now you need to do what? Find the radius convergence using the ratio test. Why would we decide to use the ratio test? Because looking at this, the obvious choice is the ratio test. Radical test doesn't make sense. I mean, if you want to, I guess you can, but ratio test is the easiest thing to do. All right, so since you can use f, derivative, or integral of f, all have the same radius of convergence, you should choose whichever form that is easiest to find the radius convergence. So in our case, which one we decide to use? Derivative, that's right. All right, so this is the one that I added. This is the one that you didn't have on, but I added this one. I made this one. So f is equal to this. So what is it then? Your u sub n is what? Your f prime. U sub n plus 1 is what? You adding 1 to all the n that you see. So you have x to the n minus 1 plus 1. So you simply have what? X to the n. Now what do? Plug it into your ratio test. If you plug into ratio test, what do you get? U sub n plus 1 n plus 1 is what? X to n. And then u sub n is what? X to n minus 1 right here. Now what can you say? I want to cancel out the common term. So can I rewrite x to n as what? That's 1 times what? X to the 1. Are you with me, class? Now, can I cancel this one out? Yes. So I only have X. Remember, you're taking limit, n goes to infinity. I don't see any n. I can bring x to in the where? In the front. What does this really mean? X times what number? 1. So you only have a 1. So what's your radius then? 1. All right, so thus the radius is 1. Okay, now. So what do I know? We know radius is what? 1. But do we know -1 and +1 is included? No, that's called what? Endpoint test. Okay, that's the one that you asked me a question about. So let's go and do it. Okay, so Wyatt, you have this one. I'm going to upload it to you guys, okay? Okay, now let's look at that. What is it?
We don't have this.
You don't want to, no, I will put it up today after class. The one that you have in your PowerPoints, this, you don't have this. Yeah, you don't have it because I just added this morning. Okay. Because I didn't like how the website, like the Cengage made it, so I added up. Because Cengage just trumped up everything and said, this is. It didn't tell you why this is. So I put it up so you know why this is. Okay, considering the interval -1 and 1, you have the following. You need to check what? The endpoints of each function. So let's do it then. The integral form. Remember, we have to do integral form. We have to do what? Regular function, and then also we have what? Derivatives. I'm going to work with the integral one first. Okay? Remember, for the endpoints, each one has different answers. Is everybody with me? The radius convergence is 1 for function, derivative, antiderivative. But the endpoint, you don't know. So what you have to do? You have to check for each different function. So I'm going to start with integration one. Are you with me, class? Okay. Can somebody tell me what am I going to say here? What do I need to put integral or do I need to put the sum? Sum. So I need to go home. I need to change this. Okay, I will update this one. So right way should be what? Sum. This all means the sum. Are you with me? So I use a LaTeX. I probably use in instead of a sum. Are you with me, class? So it should be sum. I made a mistake. It's a sum. Okay, sum. So first thing what you have to do, you plug in 1 as x. So I'm plugging in x as what? 1. 1 to the any power is what? 1. So I can simply write down 1. So 1 over n squared plus n. Is everybody see it? N times n is n squared. N times 1 is 1. N. Okay, so this one you can do what? Like a direct comparison. Remember, if you look at just this, 1 over n squared, what can you say? It converges. Why? The p is bigger than 1. So you're going to say, oh, by direct comparison test of what p series, you can say what? This converges. So in other words, the 1 converges. So 1 is included. We can conclude x equal to 1 is included. Now what do you need to do? X what? When n equal to what? -1. So you plug it in. -1 to the n plus 1. So -1 to the, again, I made a mistake here. I will fix it. After I fix it, I'll put it up. It's -1 to the n plus 1. Yeah. So -1. So let me just rewrite it. So this should be -1 to the n plus 1. That's what it's supposed to have. Okay. Again, you're going to say what? Remember, whenever you have a -1 in the front, it's alternating. That means your converges. Are you with me, class? So that's the, if you have a -1 to the whatever power, you know right away it converges. Okay, so you're going to say it's alternating series. By alternating series test, we can also what? -1 is also included. So what is your radius of convergence? The radius of convergence is what? -1 included, and then what? 1 included. All right, time for you to do the work. Okay, get together. someone needs to solve. The real answer is what? -1